Hello. In this work, we are going to present development of real-time embedded application for drone systems. At the first time, we will introduce a real-time application for embedded system. Secondly, we will introduce we present real-time operation system and why we use it, and we will see the advantage of using such application or such operating system. After that, we will present our system architecture. After, we will see tasks scheduling used by or monitored by FreeRTOS. Next, we will discuss our results. Finally, we get a conclusion. In recent years, embedded systems have become significantly complex due to the growing demand for intelligent, fast, and reliable electronics solutions. As these systems are used in several applications such as vehicles, industrial automation, and robotics, the need for real-time systems has become essential. The time contrast is one of the several concepts required for those systems' efficiency. On the other hand, a real-time system is designed to perform tasks within strict timing deadline, where the non-respect of this requirement can lead to certain consequences. In this part, we are presenting real-time operating system, where designing a multitasking embedded system application based on microcontroller often requires the use of an operating system. This need arises from the goal of achieving good performance with low development cost. In this context, FreeRTOS is lightweight, portable, preemptive, and open source real-time operating systems for microcontrollers. Its main advantages: real-time execution, open source code, and small memory make it ideal for embedded system with limited resources. In this part, the system contains two essential parts. The drone. The first part is the drone, which is or the first type, or the first part, which is the drone system. The system includes an Arduino Mega or a microcontroller unit, USB COM32, a gyroscope module, and an RF to send the data sensors. On the other hand, the ground station system contains a microcontroller of type Arduino Mega, a joystick for manual control, a PC to display sensors data and control the video acquisition, where the PC is connected with Arduino via serial communication, and finally one NRF module to receive and send data. In this part, we will see we are seeing the task scheduling throughout the FreeRTOS. In the drone level, we can distinguish four essential tasks. The first task is which has the highest priority, is the command reception task. The second priority go to the data acquisition task. The third priority goes to the data transmission task. Or we can see here the lower priority is for starting and stopping the streaming task. Uh, for the task scheduling via or through the FreeRTOS, we can see here uh, the highest priority tasks or task is which has the lower periodic or the lower period time. Uh, the deadline of the first priority task is estimated by 4 and executed time by 2 time unit. The second priority is or the kernel or FreeRTOS is can occupy this the second task in this idle area, or in this idle time between 2 and 3 unit time, and can handle by assigned a period of or estimated by 10 unit time. In this example, unit times can be equal to milliseconds. So if we can say 10 unit time, it's equal to 10 milliseconds. For the first or for the first or for the third task, it can execute it from 3 to 4, and the period of this task is around 10 milliseconds. For the last task, it's around or the period of the last task is around is estimated for 10 milliseconds, and the execution time can be handled from 6 to 8 milliseconds. So in the other hand, or in the ground station system, we can get 4 essential tasks. The first task, which is the highest priority task, is the command transmission task. For the second place, or the second priority, is data reception tasks. The third one is data display task from the microcontroller to the PC. For the lowest priority, we can see, or we can we can see the start and stop streaming task. For the task scheduling in the ground station, it's the same example as before, as we presented before. The first or the highest priority task, it has the lower period. So here in this part we are presenting our results. So we can see in this figure the streaming video via the address IP, and an interface which is developed by C# and Visual Studio platform. Here in this rubric, or this part, we can see the theta and phi and gamma generated by or sent by gyroscope module, and x and y z, which is the acceleration or the coordinate acceleration, and the temperature which is displayed or sent via the temperature sensor. In summary, this work provides a prototype of a real-time system embedded in a drone intended for aerial inspection and surveillance. All tasks were managed by FreeRTOS, while optimizing limited resources including memory and processing, lower leading to efficient real-time application based on a low-cost material. Thank you for your attention.